Here, last example here is a cosine graph. So the only difference is where the dots go, but again, the technique's going to be the same. Again, the plus one's way at the end there. So that's in my book. I'm going to rearrange it, and I'm also going to factor out that pi. All right, so again, they almost always are going to have this non-factor, so you're going to have to factor that anyway. So as you copy it to your paper, you might as well just rearrange it. Y equals 1 minus 2 cosine of pi parentheses x plus a half. Take pi out, you divide by pi, the pi on top of the pi over 2 goes away, leaving a half. So just like that, I can very easily identify the values of a, which is 1, b is negative 2, so I'm going to go up and down 2 spaces. I also know it's going to be a bow-tub. Cosine starts at the bottom or the top, negative starts at the bottom. Okay. Again, bottom, middle, top, middle, bottom, but you want to think of 0 because it's going to look like a 0. And then c is equal to pi, which means that a period is going to equal 2 pi over pi, better known as 2. That's a per dash of 1/2. And then finally, d is equal to negative a half. And again, be very careful with d that you change the sign. I keep saying it because that's what most people do. They forget to change the signs. Be careful of that. Notice 1/2 to the left, every dash is a half, so those work really well together. I can just do a basic per dash of 1/2. Notice if I just slide this over a little bit like so, if I go 1 dash to the left and then an equal spacing to the right, just like that, I've got the 5 dashes. Dash 1, the y-axis is dash 2, dash 3, 4, 5. I can say x is at a 1/2 scale because, again, that starts me at negative a half and it gives me 1 full period through. As far as y is concerned, 1 is the center line, so I'm going to put a 1 right there. And you know what? I'm thinking better of that. I'm going to put a 1 right here. Just, it's going to be the bottom, middle. Oh, you know what? I was thinking top. Where I put it, there we go. So bottom, middle, top. So just kind of figuring out where the dots are going to be so it's not in the way. And then a dash up and equally spaced dash down. And we're going 2 spaces up and down from 1. 1 plus 2 is 3. 1 minus 2 is negative 1. Here's my y-axis. And again, our layout of dots here is going to be bottom first, go up, go down, go down. So we start at the bottom, we go to the middle, go to the top, go to the middle, go to the bottom. And then we just make it look like it's supposed to. Keep in mind, these are bottom numbers, so it doesn't go like that. It kind of curls around like this as you're drawing it. All right. So the changes that we did today, again, is simply sliding it one way or the other, up or down, left or right. Again, if you just want to compare this to the regular cosine graph, if I get the right thing up here, if I just type in cosine of x, and then this is 1 minus 2 cosine of, I'm going to go with pi x plus pi over 2. My calculator's smart enough to figure out how to do that one. If you put cosine pi parentheses, it just gets to be too many parentheses in there for my liking. I need to go down as low as, let's say, negative 1.5. Well, first of all, I'm going to start negative a half. And let's see, 0.51, 1.5. So the original one goes to 3 pi, or to 2 pi, right? So let's go 2 pi for a maximum. And then scale 1's fine. And then y min, let's go negative 1.5, y max 3.5, a little bit above, a little bit below. So there's our original cosine graph. And there's our new cosine graph, which is taller and it's got a more rapid period, right? So if I just drag that out real quick, play around with it a little bit. If you just were to imagine this center line right here, there's our center line that's happening, right? And let's see, 1.5 is here, right there. So that's the beginning and end of this graph. but again, it's taller than the original graph because of the 2. It's been moved to the left because of the negative, the 1/2 pushes it to the left. So and that's cosine instead of negative cosine. The negative cosine would have started here, so I mean, it slid that way, and maybe I should have done negative cosine, but it's irrelevant now. But again, the amplitude is more because of the 2. The plus 1 moves it up 1. The plus 1/2 moved it left 1/2. The pi made a period of 2 instead of 2 pi. Okay, so all those influences on the graph. So again, it does look different in real life, but again, the way we're scaling it, it doesn't look different necessarily, but that's how it works. So again, I'm looking for this type of stuff on your paper. So make sure that you do what I'm showing you here. I'm expecting to see this, but have your y and your x-axis done properly, and that'll have the correct distortion of the graph to make your graph looks the same as everything else, the correct graph based on the scale distortion that you're using.
Okay.